specific factors model of trade. In our last lecture, we modified the Ricardian model by including multiple resources. We now entertain the possibility of short-run specificity of some factors of production, and then investigate the nature of within-country distributional losses that may result from such specificity. But what exactly do we mean by factor specificity? A factor is said to be specific to a particular industry if it cannot be relocated to an alternative production process. Usually we assume it could, but at a prohibitive cost such that in the short run it can only be used where it has been previously committed. When a factor is not specific, we say it is mobile across industries. So let us set up our model based on this modification. Assumptions of the model are similar to that which we have set up before. We have two countries. We focus again on the United States and India, two goods or industries, cloth and machines, two or more factors of production where we assume that labor is mobile and the other or other factors are specific. Markets remain perfectly competitive in both countries. The PPF is again as depicted, bowed out and concave to the origin, due to multiple factors being used in producing both goods, and this reflects decreasing rates of marginal substitution between cloth and machines. Focusing on the US, we recall as depicted in the graph, under autarky, production and consumption given by the feasible indifference curve IC1 is at point A on the PPF. With trade, the relative price of machine rises so that there is specialization in the US in the direction of comparative advantage, that is, toward more machine production, so that production is now at point B. At the new converged relative price of machines given by the slope of the line tangent to the PPF at point B, the US is able to move to a higher consumption bundle given by indifference curve IC2, which is tangent to the new relative price line at point C. As noted already, specialization is incomplete due to the concavity of the PPF. Trade, however, makes the US and India better off compared to the situation under autarky. Our concern with the introduction of specificity is to investigate how trade impacts upon the real returns to the factors employed. In what follows, I assume that in both countries labor is mobile and capital is specific. By saying capital is specific, I mean that the type of capital used in producing cloth cannot be used to produce machines. A different type of capital is required when trying to produce machines. As a result, we shall be interested in a number of outcomes. First, what trade does to the owners of labor, that's the workers, and then to the owners of capital specific to machine production, and finally to the owners of capital specific to cloth production. First, thinking about the returns to labor. Labor is paid an hourly wage equal to the value of marginal product of labor, or to the product of the price of the good multiplied by the marginal product of labor. In each industry, the wage is given by this relationship. However, because we have assumed that labor is mobile, labor would move to the industry that pays the highest wage. Under autarky, since both goods are desired and are produced, then wages have to be equalized across industries. So we can consider wages as W without any subscripts to indicate which industry they are earned in. We'll focus on the US in what follows. The labor market can be depicted in the diagram on this slide. Here we have merged the labor market for the two industries in one graph. The labor market for machines is measured from left to right, OL, and the labor market for cloth measured from the right to left, O'L. L is the total number of labor in the US. The downward sloping blue line is the machine labor demand function, which is the value of the marginal product of labor in machine production. The downward sloping green line is the cloth labor demand function, which is the value of marginal product of labor in cloth production. The point of intersection of the two lines determines the wage rate, since they are equalized across the two industries, and it depicts the split of the total US labor force between the two industries. OLM are employed in machine production and O'LC are employed in cloth production. If we continue to assume that the US has a comparative advantage in producing machines, then allowing for trade, the relative price of machines rises in the US. In the algebra that follows, we simply depict one possible scenario that leads to this, and that is where we have an increase in the price of machines and no change in the price of cloth. The result is that wages in the machine industry increase. However, as the subsequent algebra demonstrates, because of the presence of diminishing returns, the resulting percent increase in wages, which is delta W over W, is less than the percent increase in the price of machines, that is delta P over P. This is depicted graphically as follows. Given the US labor market as before, trade causes the machine demand for labor function to shift out to the right, reflecting an increase in the price of machines. The cloth demand for labor stays the same as assumed, since the price of cloth stays the same. Equalized wages, given that labor is mobile, results in more people being employed in machines, OLM prime, and fewer people employed in cloth production, O'LC prime. Wages are now higher at W prime, but the increase in the wages as shown from W to W prime is less than how much the machine demand shifted due to the post-trade machine price increase. What do these mean for the welfare of workers, or the owners of labor in the US? We investigate this by looking at the impact of real wages for both goods. First, we know that for machines, real wages has fallen because the price of machines has increased by more than workers' wages have risen. Second, for cloth, we conclude that real wages do rise, since there is no change in the price of cloth, yet workers' wages have increased. So ultimately, whether trade is beneficial to owners of labor in the US depends on what workers spend their incomes on. Now we ask what happens to owners of capital specific to machine production in the US. The answer here is implied by what has happened in the labor market. With the increase in the relative price of machines, wages rise in the machine industry, leading to mobile labor moving toward machine production. But because specialization is not complete, wages also rise in the cloth industry until they are equalized. However, the impact of trade still increases the number of workers in the machine industry. This increase in the number of workers working in the machine industry, LM, raises the marginal product of capital employed in machines. Now, consider the following algebraic relationships. The real rental income for machines, that is RM over PM, has to increase because by definition this is equal to the marginal product of capital, the MPK, which we see increases as a result of trade. Also, the real rental income for cloth, RM over PC, increases because cloth prices have not changed, but the return to capital employed in machine production, RM, has increased. This means that owners of capital employed in the machine industry unambiguously are better off regardless of what they spend their incomes on. Finally, what is the impact of trade on the owners of capital that's specific to the cloth industry in the United States? By analogous reasoning, because the number of workers in the cloth industry has fallen as a result of trade, the marginal product of capital in cloth production falls. Real rental incomes for cloth, RC over PC, falls since this defines the marginal product of capital in the cloth industry. Real rental income for machines, RC over PM, also falls because the return to capital used in cloth, RC, has fallen and the price of machines, PM, has increased. To conclude, the introduction of factor specificity into the model does not change the central results that trade increases the welfare of the countries involved in the aggregate. In our focus on home, we see this. However, factor specificity suggests that there are clear within-country income redistribution effects from trade, creating winners and losers in the process. Owners of the specific factor in the comparatively advantaged industry unambiguously gain. Owners of the specific factor in the comparatively disadvantaged industry unambiguously lose. And the welfare of owners of mobile labor is ambiguous. If they spend more on machines, they lose. If they spend more on cloth, then they gain. However, since any winners in the aggregate gain by much more than the losers lose, policy should be designed to compensate the losers for their losses. In the United States, the Trade Adjustment Assistance Program is designed to do that. But policy focus should be made on making it more extensive and precise in practice. Let us concretize our understanding of the model by looking at a numerical example. Given the same assumptions as before, and focusing still on home or the United States, we have information for the two goods in terms of their pre- and post-trade prices and wages, and in terms of their total output, quantities of pre-trade labor employed in each industry, and the quantities of specific capital employed in each industry as well. We also assume there is comparative advantage in machine production, so that with trade, the relative price of machine rises, and the percent change in the price of machines exceeds the resulting percent change in wages. We have the graphical depiction of this data, both pre-trade and post-trade. In this illustration, the price of machines rises post-trade and the price of cloth falls as well post-trade. The equilibrium value of wages rises from $40 to $44 after trade, and the number of workers in the machine industry rises from 6,000 to LM prime. However, the number of workers in the cloth industry falls from 3,000 to LC prime. Computing the impact of these changes on the owners of factors in home, we have that the percent increase in wages due to trade is 10%, but the percent increase in the price of machines is 12.5%, while the percent change in the price of cloth is a decrease of 6.25%. As a result, workers who buy cloth gain, but those who buy machines lose. We now walk through a tedious algebraic process to determine the impact of trade on the owners of capital specific to each industry. Under perfect competition, the total value of output is equal to the total factor payments, in this case to the payment made to workers as well as to specific capital employed. That's what the first two equations are saying. PMQM is equal to the product of W and LM plus the product of RM and KM in the machine industry, and PCQC is equal to the product of W and LC plus the product of RC and KC in the cloth industry. With a little algebraic manipulation, we end up with the results we see at the bottom of the slide. And this gives us the change in the specific capital rental income in the two industries. So plugging in the values from the table previously given and solving each equation for the percent change in rental incomes, we see that the percentage change in rental income in machines is 20%, but the percent change in rental income in cloth is a decrease of 55%. Clearly, owners of capital in machines gain, as this increase is much larger than the machine price increase and clearly larger than the cloth price change, which was a percent decrease. Similarly, owners of capital employed in cloth lose as their incomes fall, whereas machine price increases and cloth prices, even though they fall, do not fall by as much as their incomes have fallen. We now walk through another tedious algebra to investigate whether there are net gains from redistribution. This involves computing the real incomes before trade and after trade for both goods and for all factors. We subtract the total dollar losses from the total dollar gains. In this illustration, we see that it's possible to do so, that is, compensate all the losers from trade so that they are no worse off. And there is still a net gain of 40 cents per period. Splitting this value across all groups makes everyone strictly better off. Keep in mind that this is a classroom illustration with made-up numbers. In the real world, the net gain is usually non-trivially large and not just 40 cents. In theory, this redistribution sounds great, but in practice there are often problems such as identifying clearly the winners and losers from trade, so that who needs to be taxed and who needs to be provided transfers is difficult to implement. Further, winners may not want to provide compensation after the fact and may engage in costly lobbying to prevent this. It's also possible that the policy process of carrying out the transfer scheme is very expensive so that it's avoided. As a result, in spite of what trade promises, factor specificity often leads to opposition to trade by those who potentially stand to lose. In sum, trade still provides gains in the aggregate over the autarky situation. There are distributional implications with factor specificity though, as trade creates winners and losers within each country. The policy challenge here is to promote trade and yet provide a credible, cost-effective means of compensating losers from trade, since that is theoretically feasible and can be done, making everyone strictly better off. This concludes our look at the specific factors model, which is chapter 3 of your text. Your next step is to take the quiz associated with this lecture. Make sure to finish reading chapter 3 if you have not done so already, and get ready to get into lecture 5, which looks at the Heckscher-Ohlin model of trade. This is chapter 4, and you want to get started on that chapter as well.